Hello guys, so I am telling how to do static structural analysis in HYPERMESH on simply supported way with a pointer at middle. So we'll quickly solve this easy simulation in this HYPERMESH. So first step you need to do, select OptiStruct, the solver is OptiStruct, some of choose radius, some of choose default. So I am choosing OptiStruct. Okay, next go to materials, select steel, you can choose anything based on the problem. So color red, so it is isotropic material, I am choosing it as isotropic material. So create, return. So next, after material, go to hyperbeam, standard section, hyperbeam, a solid rectangle. So create, will go to some window, keep dimensions as 10 so it is calculated all the area, centroid and local moment of inertia, about x and y centroid, all this are calculated. So just go here, okay, return. After hyperbeam, have to give the properties of the material. Go to properties, give properties name whatever you want. 1D I am giving 1D bar. So color whatever you want you can select. So it is 1D element, so I am selected 1D. So it is bar, I am selecting bar. So material we have defined all here, beam section, rectangular, and create. So it has created properties. After properties, you have to generate nodes to give the boundary conditions. So go to nodes, select this and give origin, and then after 500 mm I am applying force, so I am creating a node at 500 mm and at last attain, create. So I am not seeing any nodes here. So if you want to see the nodes, you can click on F. So all nodes have come here. So after this, you have to create bar. So go to bar and select this one and this one. So now give properties as bar and bar. So the orientation should be Y. It is Y. Okay. So now you have to give orientation firstly, that we have to give orientation this one. So it is selected bar. So now give here to here another one. So these are measured. Now return. So next I have to give loads. Give some constraints. For constraints, give SPC, color whatever you want. We will give create. Next, force. I want to apply force, so I am giving force. Here. After this, we can see here. You can see there in this bar, you can see the load collector. Go to this and make current. Right click and make current. Go to analysis and give constraints. Select this node and give constraints. So here only rotation along. So here it is supported with hinge. So here only rotation along z direction is free. All are constrained. So give and uncheck this one and create. So next select this node. Here along rotation, the displacement along x direction is constrained, is free, and all other are constrained. So here create. Okay, you can see here these are supports are generated. So next we want to give the force. Go to force, make current, give here force along y direction, give. So I am giving downward, so it should be minus 1500 newtons. Okay, select these nodes and create. So here some problem I am facing. We can see the force acting and downwards. So the force is completed. So go to load steps and give 1D bar load step. We have SPC, that means constraints loads. Select SPC, here load force. Okay, the type is linear static, usual it is default. Create, return, the load steps are created. So next we have to do OptiStruct. Before going to OptiStruct, you have to save your file. File save is model. So I am naming it as SSB to saving. So OptiStruct. So all, export options all, analysis, memory default. So our boundary condition is completed. Now we have to check for results. So we are getting some error here. Material ID, so yeah. So here you can see here I am getting this error because of material. So firstly you have to do, the first step you have to do is you have to select this E and enter, and this Poisson ratio and enter. So you avoid this type of errors, we should select this one. So now the steel has selected. So we will try once again whether it is completed or not. Now you see the analysis completed. So you avoid the solution, we have to careful firstly on material. Okay, we can go see the results now. So now do this contour plot. Displacement, it is in displacement. I want to see in y direction. So click on y direction and apply. You can see here you can see the maximum deflection at middle. So because we have updated the load at middle, so at both ends the displacement is 0. Okay, you can observe the animation also. So we will see the stress here. Stress along there is no axial stress here because only force in y direction, so there is no axial. So these are the results we got. Okay, so thank you.